In this example, the diagram shows vectors A, B, and C, and we need to draw a diagram to illustrate the vectors addition of A, B, and C. So we can see the vector A going in this direction, so that's A, and we can see to add it to B, we'll be looking in this direction, so we connect B also in this direction, and also we have vector C and going in this direction here. Now, for us to find the addition of A and B, we can connect dotted line in this direction, so that would give us A plus B. And now if we want to find A plus B plus C, we will have a vector going in this direction where it connects A to C, and this will be the addition of A plus B plus C, and this will be the solution for this question. In this example, we have the vectors, we have a diagram of QP equal A and QR equal B, and the vector of QS equals C and RT equal D. So find in terms of A, B, C, and D first PS. So for us to find PS, the vector of PS, we will have, so this is for first part is P and S, which is in the middle here, and so we can find it through PQ and also QS. So QPQ and QS, this one here. So adding these two, that would give us in this scenario, because it's P so in this scenario, if PQ, so we're taking it in the opposite direction, because you can see PQ, we are going in this direction while the A is going in this direction, so we have minus A, and we have the PQS, which is coming in this direction, QS. So we'll follow in the right direction, because as we are moving in this direction, will be plus C. And in this scenario, it will give us, we can either keep it as it is, or we can write it as C minus A. And this will be our answer for part A. For part B, we have the vector of RP. So for us, we will remove these, and then we come back to what, how can we find RP? So RP will be going across in this direction, which will be a combination of RQ vector, which is this one here, and also a combination of QP vector, QP. Now we will need to find the directions of both, so we can see we're going in this direction, so it will be minus B, so we're going in this direction and then we're coming back in this direction. So we can see the B is opposite, so we have to take the negative B, because B is going in this direction, and downwards we are moving upwards, and then we also have plus A, because we are moving in the right direction of A. So we can either keep it as minus B plus A, or we can write it as A minus B, and this will be our answer for RP. For part C, we have PT, the vector of PT, so we'll remove our arrows, so we have PT is here, so we can find PT from PR vector, which is PR is here, and also we can find it from plus RT t vector. So we have PR vector and RT vector. Okay, so we're moving in this direction and in this direction. So in this scenario, we found PR in the previous answer, which is a combination of B minus A, and so what we would have here, B minus A, and we also have, we're moving in the right direction of D, so that will give us plus D. So in this scenario, we have, so we can write it in a different, you can either keep it as it is, or we can write it as B plus D minus A, which will be our answer for finding the vector of PT. For part D, we remove our sketch, and then we look at finding the vector of TS, so which will be coming from TR vector plus RS vector. So TS is this one here, and it's coming from TR, which is this one here, and RS, which is this one here. So now we know RS, it comes from two vectors, so we know TR is, and we're going, because we're moving in this direction, coming back here, so we're moving in this direction and then coming back here, so we're taking a negative D, plus RS, it comes from two vectors, which is RQ vector and also QS vector. So that will give us minus D plus QR, comes, so the combination of the two will be minus B plus C. So to simplify this expression, we can write it as C minus B minus D, which will be our answer for finding the vector of TS. In this example, we have the ABCD is a parallelogram, and we have AB vector equal A or AD vector equal B, and we are asked to find the vector of AC. So first we'll need to find in terms of what would AC will be a combination of. So it will be a combination of AB vector, which is moving in this direction, and also plus BC vector. So it will be moving in this direction and also in this direction. So moving in this direction and in this direction. So to find BC, that tells us that BC, because it's a parallelogram, BC will be equivalent to AD, because BC will equal AD, and that will be equivalent to B. So that tells us that AC, the vector of AC, will equal A. So that tells us that this vector will be B. So that tells us the vector of AC will be A plus B. And this will be our answer for this question. In this example, we are asked to show that the vectors 6A plus 8B and 9A plus 12B are parallel. So for us to prove that, we have 9A plus 12B, and in this scenario we'll equate it to 2/3. So in this scenario we'll take the alpha for the parallelogram being multiplied by 2/3. So where 2/3 is 3/2. So that means we will multiply the first vector by 3/2. So that will give us 6A plus 8B to prove that if it aligns. So if we multiply the first vector by this value, it will give us 9 a plus b. So that's approved. So then the vectors are parallel. So this is we multiply one of the vectors by a factor, and if it gives us the same value, that will prove to us that the two vectors are parallel. And this will be our answer for this question.